So, hi everyone and doctor. My name is Ana Nushada binti Muhammad Zamri, and I will be presenting BST based for student management system. So, this is the table of contents for my part, my system. So, we have system overview, the core node, key function insert, search, delete, the system demo, and then improvement for the next draft. So, for the system overview, the objective is to develop an efficient cost-based system, which is C++ will be using terminal for the output. So, this system is for managing student records, and then uh, the system employs a binary search tree BST implemented in C++. So the key features. So for add, it captures student ID and course code, which is the primary key, and then search, which is instant lookup via student ID and course code as well, and then display, which is auto sorted alphabetical student list and course code in a table view. And then when we remove withdrawn or graduated students from the system or remove unavailable course code. So why BST? So BST is efficient. So for faster search and insert by O log n and linear arrays, which is ON. So for the scalability, dynamic memory allocation pointer allows unlimited studio record, which is will be growth year by year. So the first part is the core node. So we have start student. So the data is the student object. So the left pointer point to a smaller alphabetical, where right pointer larger alphabetical. So the sorting logic is three straightly organized by the student ID. So as I mentioned, parent in the middle, left side is for the smaller, the right side is for the larger. So we can see for the example here. So this is the student ID we have S005, S001, S009. That is for the example. Next, the core node for the course, track course. So data is the course object, sorry. And then for the left pointer with smaller alphabetical course code. So larger side will be the right pointer. So what the alphabetical means? So we have, let's say, MECS. So and then we have MECB. So MECB will going to be the right side because it is larger than MECA. So we have here for the example of the sorting logic. So smaller suffix is MECA 2023 and the larger suffix is MECS. So let's say MEBA. So MEB is smaller than MECA. And then key function insert for student. So we have the logic by recursive comparison. So if the tree is empty, we create the root. So if the new student ID is smaller than the current, so we recurse left. So otherwise, the student ID larger than the current node, so it recurs right. So the duplicate student IDs will flag errors to prevent data duplicate, corruption. So we can see here in the code which is mentioned, the student ID already exists. Same goes insert function for the course code. Similar logic, similar flow, and then if the course already existed, it will appear error message which is course already exists as shown in the code above. Next, the key functions search for student. So binary search principle. So we check if the current node match the student ID. If not, we eliminate half of the tree instantly by choosing to go only left or only right. So we can see the coding here. Similar searching logic goes to the course code as well. Okay, now let's look at the delete function. So also called the remove internal. So this is the delete function at the student part. So how it works in a binary search tree. So when we delete a node, our main goal is to make sure the tree stays sorted. To do that, the delete logic handles three different cases depending on how many children the node has. So we have the flow here, flow 1, 2, 3. So it means case 1, 2, 3. So case 1, the node is a leaf. So if the node we want to delete has no children, so this is the simplest case. We just remove it directly because the thing doesn't affect any of other part of the tree. So case 2, let's say have one child, and then we can't just delete it because that would disconnect the whole subtree. So instead we bypass the node, meaning we link the parent directly to the node's child. So the node gets removed and each child slides up to take its place. So the last part is number 3, in case they have two children. So this is the most complex case. So when the node has two children, we need to keep the binary search tree property intact. The tree kept intact. So the standard way to do that is to replace the node's value with its in order successor, which is simply the smallest value in its right subtree, and then after copying the value over, we then delete the successor node, which is guaranteed to fall into one of the easier cases. So overall, the delete function maintains the sorted structure of the tree by handling each of these three cases appropriately. So this is the key function delete for the course code. So the logic is the same as the student ID. Hi everyone, Dr. So right now I will do the system demo only, as I already explained the part functionalities in the previously. So, uh, so next, I would like to sorry to Doctor because right now my Visual Studio Code having some problem. So I will do the system demo here inside the online compiler. So we'll run the system now. So tada, this is the system main menu, which is UTM, Student Management System. So we have three part here, which is first student details, which means the student section display add, insert, delete, and then course details means course section, add course, view course, delete course, and then exit the terminal, the number 3. So let's go through the student details. So we have add student, search student, display all student, delete student, and back to the main menu. So we'll do the add student first. So we have enter student ID. So let's say uh, S202. So we need to put name. So let's say Najiha. So enter the department, which is Department of Computing as me. As well as me. And then GPA, let's say 3.5. And then year level, let's say year 3. Same as me. So it mentioned here student added successfully. So we like to check whether the student detail inside the table or not. So we choose number 3, which is display all students. So yes, we can see here, which is some of the name is my group member Azri Ashmi, Alia, and then Guna. So this is their department, GPA, and year. So and then we like to add another student. Let's say we like to check if we enter one of the student ID here, what will happen. So let's say we enter uh, Najiha ID S202, and then enter the name, let's say Amirul, and then their department, let's say civil engineering, and then GPA, let's say 3.66, and then let's say year level, I mean year 1, let's say. So it mentioned here error, student with ID already exists. So because S202 is belongs to Najiha. Next, we have here to add another student because we would like to add student just now. And then let's say we enter others number X604, let's say. So enter name Amirul, enter the department, civil, CGPA 3.66, and then enter year level, which is level year 1. So student added successfully. So check again whether inside the table or not. Display of students. So we can see here Amira is under Guna because this number, this student ID is larger than S505. So we like to delete student. Let's say we would like to delete Najiha. So we delete S202, S202. So we check again whether delete complete as mentioned here. We check again. 3. Oh no, yeah, 3. Display all students. Yes, so Najah is no longer inside the table. So we're going back to main menu, which is number 5. Back to main menu. So let's check the cost section, cost data section. So number 2, this is the main menu. So we check number 2, and then let's display all courses, which is the preloaded data. So here is the course code, course name, and credit. So here the course code is the unique ID, so which is the primary key. So let's say we would like to add um course, and then let's say the course is MECA 2025. Enter the course name, let's say Advanced AI, with the credit hours 5. So it mentioned here course added successfully. So you like to check whether inside the table or not. So display of course here. So in the character, A is come first, then R. So let's say we like to add another course with the same code. What will happen? With the same course code, what will happen? So MECA 2025, and then we add the course name, which is, let's say, another course name, which is we can have advanced, no, not advanced, mm, advanced computer science. We have that, right? A1 computer science, and then credit hours, let's say 5 also. So we cannot add the course because the course code with this course code already exists. So, and then we check what will happen to the table. So it stay the same as previous. So next we add another course, which is MECB 2032. Let's say like that. And then we add the course name, which is what we have, pen test, penetration testing subject, pen test, and then credit hour, let's say 2. So course added successfully. So we check this pair of course. Yes, so the character B came second, then A. So pen test in the second line. So let's say we want to delete course. So number 3, delete course. Let's say we want to delete advanced AI. So MECA 2025. So it mentioned course deleted. We can check again the table whether deleted or not. Yeah, so course advanced AI is no longer in the table. So that's all. Going back to the main menu. So that's the student management system. That's all. Thank you. So for the next draft, for the task 3 assignment 2, so and then before the final submission, I will try to complete the coding inside Visual Studio Code and write in my own terminal instead of the online compiler. So and then beside that, the main important parts, maybe in the next draft, we can improve by the GPA alerts where uh, students with GPA below than 2 can have warnings in the academy dashboard because as we know below than that usually will be removed from the university and cannot take any semester. Then we have file persistent, which is implement save to file or load from file, so the data can be retrieved or uploaded and is not lost when the console is closed. And then lastly is department grouping. So we can add category grouping to view student by department. For example, we have just now computing, so we can list out all of the students under the computing department faculty. Thank you very much, everyone. Bye bye.